These are notes 9C, recursive equations, and word problems. All right, so we have two more equations that we're going to use for our arithmetic and geometric sequence. The word recursive means a repeated application of a rule. So you notice in the arithmetic one, we're going to add a common difference each time. So that D. And in our geometric, we're going to multiply by a common ratio. So these forms are a little bit different than the ones we used before. Let's look at a couple of examples. Let's look at an arithmetic one first. I know it's arithmetic because I'm adding 7. That's my common difference. All right, notice here we start, it's a little bit different formula. We're going to start with our beginning term, which is our a sub 0 term, which is 3. And then each consecutive term, we're going to add 7. So in recursive, so that means we want to find the fourth term here. So that means I can't plug directly into my formula because I need the previous term in order to find the current term. So I've got my first, my a sub 0 is 3. I want to find a sub 1. So I'm going to use my rule. I'm plugging in 1. Okay, so I'm plugging in 1 in for n, and that gives me a sub 0 plus 7. Well, a sub 0 I know is 3, so I'm going to put 3 in the place of a sub 0. So 3 plus 7 is 10. So my first term, a sub 1, is 10. Notice we're starting the sequence at a sub 0. Okay? All right, now I need to find my second term. So that means I'm going to take 2 and plug in the place of n. That's going to give me a sub 1 plus 7. Well, from the previous problem, I found that a sub 1 was 10. So 10 plus 7 is 17. So a sub 2 is 17. All right, we're going to continue this pattern, that recursive pattern, adding 7 each time until I get to my desired term, which in this case is my fourth term. Okay, a sub 3. So that means we're going to plug in 3 in for n. So 3 minus 1 plus 7. So a sub 2 plus 7. Well, a sub 2 I know is 17. 17 plus 7 is 24. So my third term is 24. All right, one more time. So now I need my fourth term, and that's what I'm asked to find. That's where I can stop. So I'm going to plug 4 in for n. So a 4 minus 1 plus 7. So that would be a sub 3 plus 7. Well, from the previous example, I found that a sub 3 was 24. 24 plus 7 is 31. So that means my final answer here is 31. So that's where I was asked to stop. So recursive, we just use the same repeated application over and over. In this case, the adding 7. All right, let's look at a geometric one. I know it's geometric because I'm multiplying by a common ratio, in this case 2. All right, same general procedure though. Same process. I'm starting with my 0 term, which is negative 4. So I'm asked to find my third term, a sub 3. So let's start with a sub 1. I've got to find the previous term in order to find the one I'm looking for. All right, so plug in 1 in for n. So we're going to get 2 times a sub 0. Well, they told us that a sub 0 was negative 4. So that means my a sub 1 is negative 8. All right, let's do the same thing for my second term, a sub 2. So I'm going to plug 2 in for n. So 2 times a sub 1. Well, I found that a sub 1 was 8, negative 8. So 2 times negative 8 is negative 16. And then finally, he asks us for the third term, so we're going to do this one more time. So plug 3 in for n. So 2 times n minus 1, which equals 2 a sub 2. Well, I found that a sub 2 was negative 16. 2 times negative 16 is negative 32. So that means my answer is negative 32. Next, we're going to look at some word problems. So let's look at a first example. And retirement. All right. You invest $20,000 in a retirement plan. The plan is expected to have an annual return of 12%. We want to write a rule for the amount of money A sub n available in the plan at the beginning of the nth year. What is the balance of the account at the beginning of the 20th year? Okay, so let's decide what kind of problem this is. Because we're earning a factor of 12% each year, all right, this is going to be geometric. But you always start off with, we're not going to be multiplying just by 12%. We have our initial investment, which was that $20,000. So that means 1 plus my 12%. So that means my ratio is going to be 1.12. All right, my initial amount, my A sub 1, was $20,000. So that means our general rule is going to be my initial amount, my $20,000, times my ratio of 1.12 to the n minus 1. So there's my general rule. All right, so we're going to leave this money alone for 20 years. How much money are you going to have at the end of 20 years? So that means we're going to plug 20 in for n. Okay, so plug 20 in for n. All right, put that in the calculator, and you're going to have $172,255 after 20 years if you invest $20,000 with an annual return of 12%. Not too shabby, so start saving now. All right, let's look at another example. A pendulum. A pendulum is released. It swings forward, traveling a distance of 120 centimeters. On each successive swing, the pendulum travels 97% of the distance of the previous swing. So it's got less distance each time. Find the total distance. This total distance traveled by the pendulum in the first 12 swings. Okay, so not the amount covered in the 12th swing, but the total amount that it swung. Okay, so hope again, like they say, we're decreasing, but we're getting 97% of the previous swing. So that's still a ratio. All right, 0.97. So that means this is a sum of a geometric series. All right, so let's plug in the values that we need here. So our initial amount that we traveled was 120. All right, our rate is 97%, or 0.97, and it's on our first 12 swings. All right, so here 1 minus r, so that's at 0.97. All right, here again, be very careful putting that in the calculator, but you should get the totals. It covers a total distance in the first 12 swings of 1,222.63 centimeters. All right, last problem. Part-time job. You take a part-time job that involves working the same hours each week. Your take-home pay for 4 weeks is $258.28. All right, we want to write a rule for the total amount of take-home pay you earned by the end of the nth week. So, first of all, we need to decide how much money do you make a week for 1 week. All right, so we're going to take the total amount of money you made, and we're going to divide by 4. So that means for 1 week, you make $64.57. Now to write your rule, we're going to multiply by the number of weeks. So A sub n is equal to the money for 1 week times n, which is the number of weeks. So there's our rule. All right, so what is the total amount of take-home pay earned after 27 weeks on the job? All right, so n is 27. So we're going to put So we're going to multiply our money per week times 27. So at the end of 27 weeks, you will have made $1,743.39. All right, after several weeks, your total gross pay is $507.50. 4 weeks later, your total gross pay is $797.50. What is your weekly gross pay? So you've gotten a raise. We want to figure out how much per week have you gotten a raise, or how much are you going to make now after your raise. Okay, so after some disclosed time, so several weeks, plus 4, you're going to make $797.50. So what the first thing we need to do is to find that difference from what you're making now and what you made before. And then we're going to divide that by 4, because we know you're going to make that amount of money in those last 4 weeks. So that means those last 4 weeks, you made $72.50 per week. All right, we're going to practice some more of these in class. If you have any questions, please let me know.